Hi, I'm Jacob Wagoner, and I will be going over a question I created using Newton's second law of motion. My question is: a student pushes a 3 kilogram box across a smooth floor with a constant force of 12 N. What is the acceleration of the box? How this question fits the project. This question directly uses Newton's second law: force equals mass over acceleration, which or force equals mass times acceleration, which is the core concept uh, the project is built around. It helps demonstrate the relationship between force, mass, and acceleration using simple values that match the types of experiments discussed, like pushing carts on air tracks or using sensors to measure motion. It also aligns with the experimental procedures used in both Newton's time and modern day labs. Why this question matters? This Newton's second law of motion question matters because it teaches fundamental principles of how the world works, how force causes objects to accelerate. Understanding this is key to unlocking countless real world applications. It's also practical with the numbers I use, and whether you're designing safer cars, programming robots to walk, or launching a rocket, you need to calculate how much force is required to move something. This question helps lay the groundwork for making those calculations accurately and confidently. How I developed the question? I developed this question by starting with the core formula from Newton's second law of motion, which is force equals mass times acceleration. Where and I knew the question needed to be clear and measurable and use realistic numbers. Directly tested understanding of the relationship between force, mass, and acceleration. And so I chose a simple everyday scenario, pushing a 3 kilogram object with a force of 12 newtons. And it keeps the math straightforward but still meaningful. It makes it easy to apply real world logic and allows for immediate application of the formula. Acceleration equals force over mass. How it's unique. This question is unique because it is intentionally designed to connect Newton's law to a realistic and reliable context, which still being clean and simple enough to focus solely on the core relationship between force, mass, and acceleration. Unlike many textbook problems that either plug in generic values without context or add unnecessary complexity, friction, angled forces, or multiple steps. What sets it apart is clarity of purpose. It does not distract from the law being tested. Approachable math. Numbers are chosen to reinforce conceptual understanding, not just test math skills. It has a strong alignment with lab experiments. The scenario could be recreated with a cart and a force sensor on an air track, mirroring modern lab setups used to demonstrate Newton's second law. And its scalability. The question could be extended into multiple step problems, for example, finding time or distance without changing its core structure, making it adaptable to different learning levels. Data table, force, mass, and acceleration. This table and explanation demonstrate how Newton's second law of motion, force equals ma, F equals ma, used to calculate acceleration when the force and mass are known. So in the table, you know your force is 12 newtons. The mass of the object is 3 kilograms. And when you find your answer, it's going to be 4 for acceleration. 4 ms squared. key formulas. The primary formula is force equals mass times acceleration over force. And then to solve for acceleration, you want to rearrange the formula. So it's going to be acceleration equals force over mass. And then plug in the given values. Force equals 12, mass equals 3, acceleration equals a. Acceleration is a. 12 over 3 equals 4 ms squared. Solving the question step by step. To solve for this problem of finding the acceleration of a 3 kilogram box being pushed with a constant force of 12 newtons across the smooth floor, we start by understanding the relationship between force, mass, and acceleration. According to Newton's second law of motion, acceleration is directly proportional to the net force applied and irreversibly proportional to the mass of the object. This means acceleration can be found by dividing the force by the mass. First, we identify the force applied, which is 12 newtons, and then the mass of the box, which is 3 kilograms. Since the floor is smooth, we can assume there's no friction opposing the motion, so the net force is equal to the applied force. Next, we use formula. Acceleration equals force divided by mass. Substituting these values into this formula, we divide 12 newtons by 3 kilograms. This calculation results in an acceleration of 4 meters per second squared. Therefore, the box accelerates at 4 meters per second squared in the direction of the applied force. The final answer and relevance. The final answer is that the box accelerates by 4 meters per second squared. This means that for every second the box moves, its speeds increase by 4 meters per second. The relevance of this answer is that it shows how much the box's motions changes when a certain force is applied. Understanding acceleration helps us predict how objects will move under different forces, which is important in physics and real-world applications like engineering, transportation, and safety designs. In this problem, knowing the acceleration helps explain how quickly the box will speed up when pushed. And here are my sources that I used. I went on Hyperphysics, Physics Classroom, and Khan Academy. I don't know if I said that right. But this has been my question is with the answers explained and everything else.